Spartan fans, let's look at the chain rule part 2 and what happens when I want to differentiate. Instead of differentiating with respect to x, I want to differentiate with respect to t or respect to theta or some other function. So let's take a look first at something like r equals the secant of 2 theta times the tangent of 2 theta, and I want to find the derivative of r with respect to theta. I have my function r, and I want to differentiate with respect to, in this case, theta, which represents an angle measure. Okay, we're going to use the product rule and combine that with the chain rule. So the product rule says that dr d theta is going to be the secant of 2 theta times the derivative of the tangent 2 theta times tangent 2 theta prime plus the tangent of 2 theta times the derivative of the secant 2 theta. So secant 2 theta prime. Let's look at finding a second derivative. So let's say you have y equals 9 times the tangent of x over 3. So keep in mind that's 9 times the tangent of 1/3 x. And I want to find dy dx. I want to find the second derivative. Well, of course, we have to start by finding the first derivative. So let's start with y prime. So the derivative of tangent is secant squared. X over 3 is clearly prettier. I'll fix that in a second. So this is the derivative of tangent x over 3, but you have 1/3 x, and the derivative of 1/3 x is 1/3. So essentially, dy dx is, how about 9 times 1/3 is 3. Okay. Now we need to find the derivative. If I want to find the second derivative, I'm going to take the derivative of the first derivative. Okay, great. Okay, so the derivative of the secant is going to be secant tangent, but kind of have to do this in steps. So I'm going to use the power rule. So by the power rule, I'm going to bring the 2 out in front. Decrease the power by 1 times, by the chain rule, the derivative of what's inside. So the derivative of secant, we just said, was secant tangent. And then times the derivative of 1/3 x, which is 1/3. And I forgot the 3 that was here. So put that 3 down. Forgot the 3 that was in front. And then the derivative of 1/3 x is 1/3. Think of it this way. This is 3 secant x over 3 squared. So you've got the 3 out in front, 2 comes down, derivative of what's inside to the first power. And then I took the derivative of secant x over 3, which was secant tangent. Okay. I believe this is 2. And we have you know what? I did not forget the 3. The 3 is right there. I did not forget it. It's right there. 2 secant squared x over 3 times the tangent of x over 3. Secant x over 3, secant x over 3 is secant squared times the tangent of x over 3. Parentheses, no parentheses. That is the second derivative of 9 times the tangent of x over 3. Okay. Is the f of g of x equal to the g of f of x? And the answer to that is sometimes, but not always. With the chain rule, it's going to be true. So let's take a look at something such as y is equal to the sine of x squared plus 1. And I can write this a couple of ways. So I can say that y is equal to the sine of u plus 1, where u is equal to x squared. So let's take care of it that way first. Okay, so by the chain rule, dy du is the derivative of sine is cosine. And du dx is by the power rule 2x. So I'm going to multiply the 2 together. So dy dx is the cosine of u plus 1, but u is x squared. Times the derivative of u, which was 2x. Okay, so that's one way to do it. Okay, another way to look at this is say, let me just rewrite this, sine of x squared plus 1. And you could say y is equal to the sine of u, and u is equal to x squared plus 1. Just a different way to make the composite. All right, well, dy dx is equal to the cosine of x squared plus 1. So the derivative of sine is cosine times the derivative of x squared plus 1, which is 2x. So hopefully you recognize 2x here. And then the derivative of u is 2x. Okay. So let's go back. The derivative dy dx is just cosine. The derivative of, wow, I totally messed this up. Let's try that again. Dy du, let's start this again. Dy du is cosine of u. Du dx is 2x. So dy dx is equal to the cosine of u. And u is x squared plus 1. Man, the lighting on this is so bad. And then du dx is 2x. Same answer either way. Try to adjust the view. It's not so great, but I like to go back to this one because I totally messed it up. So the same function, y equals sine of x squared plus 1. And with the chain rule, it's a composite function. And there's two ways to write this as a composite function. So the first way is take out x squared and put in u, and therefore u is x squared. And this one's great. This one, you can take out x squared plus 1 for u, and then say u is x squared plus 1. So the derivative of y with respect to u is cosine, and the derivative of u, the function u, with respect to x is 2x. Multiply them together, you get cosine u times 2x, and u is x squared plus 1. So I did a substitution. Okay. So earlier I had said, I can differentiate y with respect to x because the variable in the function is x. And here I can differentiate r with respect to theta because the function is r and the variable is theta. So what happens when I want to differentiate a function with respect to a variable that is not part of the function? Okay. So let's say you have x is equal to the sine of 2 pi t. Already this is an issue. X's and t's. Not so sure what's going to happen here. And we have y is equal to the cosine of 2 pi t. This is a cyclical sine curve. This is a cyclical cosine curve. The period would be 1. The coefficient on t omega, as we used to say, is 1. 2 pi over 2 pi is 1. 2 pi over 2 pi is 1. So this is just a curve going on and on and on and on. Okay, so the question's going to be, I want to find the equation of the tangent line. Boom, derivative. So I want to find the equation of the tangent line. At t equals negative 1/6. Okay, so right away, tangent line, derivative. I don't know what's going on with the lighting, but I don't know. Can't seem to figure it out. When all else fails, turn it off and turn it back on. And that seems to be a bit better, at least on my end. Okay, so equation of the tangent line, that's the derivative, great, dy dx. Dy dx. The derivative of y with respect to x. What's going on? How about instead we take the derivative of y with respect to t and we divide that by the derivative of x with respect to t. That looks a whole lot better when you divide, right? This is dy over dx, and I can differentiate y with respect to t. The function's y, the variable is t. The function's x, the variable is t. So this I can do. All right. First, let's find dy dt. So the derivative of y with respect to t okay, so the derivative of cosine is negative sine. Then the derivative of 2 pi t is 2 pi. So this is going to end up being negative 2 pi sine 2 pi t. Take a look at that. All right, let's look at the derivative of x with respect to t. Okay, the derivative of sine is cosine. And the derivative of 2 pi t is 2 pi. Chain rule. That's the chain rule. Cool. Now I divide them. So dy dx is dy dt over dx dt. So dy dt we just found was negative 2 pi sine 2 pi t. So dy dx is going to be negative 2 pi sine sine 2 pi t over dx dt, which we just found out was 2 pi cosine 2 pi t. And of course, sine 2 pi t over cosine 2 pi t is tangent 2 pi t, and then negative 2 pi over positive 2 pi is negative 1. So let me just do it over here. So this is negative tangent of 2 pi t. Okay, well, I want to find out, so this is the slope. This is the slope of the tangent line at any point t. And now I want to find out at negative 1/6. Okay, so at negative 1/6, plug in. Negative tangent 2 pi times negative 1/6. This is the negative tangent of negative pi over 3. How about negative 60 degrees? How about that is going to be pi over, not pi over 3. I think that's going to be root 3 over 3. Yep, this whole thing ends up being positive root 3. Okay, so this is the slope. That's not the equation of the tangent line. So I also need to find out what are the coordinates at t equals negative 1/6. This is going to be tough because initially we say, oh, okay, you have your variable x, you plug it back into the original function, blah, blah. But there are two functions. There are two functions going on here. So my x coordinate is going to be where t is negative 1/6. And my y coordinate is going to be where t is negative 1/6. So these are two different functions. So to find x, I need to plug in. So to find x, I'm going to have the sine of 2 pi times negative 1/6. And to find y, it's going to be the cosine of 2 pi times negative 1/6. So the difference between this equation versus ones that we've been doing up until now, two functions. These are two curves. So this is going to be whatever, I don't know. The sine of negative pi over 3, which is negative root 3 over 2, 60 degrees. Right now, the unit circle should be second nature. This is the cosine of negative pi over 3, which I believe is positive 1/2. Here are my coordinates. Here's my slope, point slope form. So this is going to be y minus 1/2 equals m, which is root 3 x. How about plus root 3 over 2? So I've been saying all along that point slope form is okay. Your book is constantly using slope intercept form. So this is going to give us root 3x. This is 3/2 plus 1/2 plus 2. So this is the chain rule, part 2. It gets complex because you've got more than one equation, and then you're deriving with respect to x sometimes and with respect to t sometimes. Question that you might have is, why are we doing dy dx? Because it's always I can't think of a time that we're going to do dx dy, at least not yet. So dy dx, etc. Okay, so that's the chain rule part 2. Problems get to be pretty intense, but I'm confident you can figure them out.